Okay, just watch. Okay, from scratch I will do in order logically, so just watch and understand. So most important parts will be covered here. First of all, we will understand. So in trigonometry, the first thing we'll understand is this. You have x here, angle. It's a right angle triangle here. Suppose this is PQR. So you write sin x here, Q divided by R, cos x here, P divided by R, tan x here, Q divided by P. Then from here, right, from here you subject Q. When you subject Q, it's going to be R sin x. From here you subject P, that should be R cos x. Here, yeah, you can subject Q, but I'm not interested. You can do it. Then this is a right angle triangle. So I'm going to use P theorem. Pythagoras. Okay. So if I use Pythagoras theorem, you get R squared is equal to Q squared plus P squared. So now I see here that Q is here, P is here, right? So if I do that, I get R square is equal to Q square is equal to R square sin square x plus P square is equal to R square cos square x. Now I told you that I'm not interested in this. There is a reason. The reason is, now when I have R squared, right, I wanted to keep R squared here, knowing that 2 R squared are coming here. So then what I can do, I can cross these three. So it's going to be 1 is equal to sin squared x plus cos squared x. And that is one important relation, the one and only important relation you should know in trigonometry for methods. Okay. Now, any questions here? Oh, it's pretty clear, right? Now, some students, I saw that they don't know this fact. Sin x multiplied by sin x. You can write sin x function, the whole thing squared. Or this is nothing but sin squared x. Same thing. Sin squared x means sin x whole thing to the power 2. Okay, so that is just a fact. Now, we are in this sin business, right? So first of all, I'm going to say fx is equal to sin x. So that goes like this, goes like that. These are infinitely extending functions. What do you mean by that? If you think about x goes to minus infinity to infinity, like that. Why? Because it goes this way, right? But if you think about y range, that y is restricted from minus 1 to 1. Okay, minus 1 to 1. But if you look into fx is equal to x squared, this one is this. So this goes to infinity, this side goes to infinity. Again, it's a infinitely extending function, but the difference between sin and this would be, here x is minus infinity to infinity, y also minus infinity to infinity. How come? Because you can see when it goes like this, x direction also goes to infinity, y direction also goes to infinity. 0 to infinity. Okay. So now what I am saying, this infinite condition is coming here in both cases, but here there is no infinite condition. This is a finite boundary in y. So in y it is restricted like that, in x spreading. In other functions like y and x are, they can go to infinity, right? So this is sin x. Okay, so now let's think about this one. Y is equal to sin x. Now what is infinitely extending is my x, right? So if you want to restrict something, right, so you have to restrict something which is going to infinity, right? So you are going to restrict here so that you can truncate the situation, right? But you don't have to do anything in y direction. Why? Because y direction is already bounded from -1 to 1. Restriction is happening in the x. So what I do, I make the restriction from 0 to 2 pi here. Now this 2 pi is 360, that bit you know, right, everybody? Yeah, that I'm not going to discuss. So I'm going to restrict here 0 to 2 pi. Now one thing we need to understand, this is pi divided by 2 here. This is pi divided by 2. Now when you are in grade 8, 9, 10, we talk about sine values, right? So for example, if this is theta, so we write sine theta, so this is PR, for example. So sine theta is equal to P divided by R, right? Now we have to understand that this theta can be greater than 0, less than 90, yeah? Because this can be like this, or this can be like this, it can go like that, right? So I'm talking about this hypotenuse, right? So the theta value has the flexibility to change from 0 to pi divided by 2. You understand that? If theta value is changing from 0 to pi divided by 2 only, you make a right angle triangle. Yeah. So if this theta value is between 0, this is 0, close to 0, and 90, then only you can make a right angle triangle. If this theta value is exceeding 90, that means this hypotenuse is somewhere here, so then this angle is more than 90. So if the angle is more than 90, you can't use your sine cos tan definition, because that definition is for a right angle triangle, right? It's a very basic thing here. Now when it comes to here, now I'm comparing this one with this here. Now you can see my flexibility in here is from 0 to pi divided by 2. So that means if you graphically see that, my flexibility here, grade 9 math, we discussed from here to here only. So whatever the values here, right, those values are between 0 and pi divided by 2 only. So we didn't talk about sine values beyond pi divided by 2 when you are in grade 9, 10, 8. You understand what I'm saying? Right. So these values we discussed. So for these theta values, for these theta values, we discussed those things, right? So few common values here in trig table. Sine 0 is equal to 0. Sine 30 is equal to half. Sine 45 is equal to 1 divided by square root 2. Sine 60 is equal to square root 3 divided by 2. Sine 90 is equal to 1. Okay. So if I ask you a question, half is greater than 1 divided by square root 2, or half is less than 1 divided by square root 2. Which one is correct?
The second one?
Second one? Why?
Oh wait. No, sorry, yeah, first one. Pi over 6 is weird.
Okay, I'll tell you why I'm raising this question. When 20 years ago, when I was learning this topic, like you, my teacher asked the same question from me. He didn't mention anything, he just put this in the board and say, it's just for the small class. He asked me, if you have 1 divided by 2 and 1 divided by square root 2, which one is greater? Yeah, of course, you can put into the calculator, or you can think of the values. 1 divided by 2 is half, 1 divided by square root is blah 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 blah, and then you can sort of get it, right? But he was expecting me to give the answer in this, knowing some facts, right? What he was targeting is this. What he was targeting. Now, he thought that I was very conscious when I was doing the class. Then, now we are in this topic, right? So half is here, 1 divided by square root 2 here. So he wants me to directly connect this with here, this with here, and then he wants me to see the angle pi divided by 6 and pi divided by 4, right? And then it's sine pi divided by 6, sine pi divided by 4, and then that I can connect with here, pi divided by what? 6 here, pi divided by 4 here, right? Pi divided by 6, this value is going to be half. Pi divided by 4, this value would be 1 divided by square root 2, right? Obviously, this is your y axis, right? So definitely it will tell you that this is greater, right? So if you get those specific values, yes, we can play like that. Okay, so I just remember that he asked me that question. Okay, anyhow, so now what I'm saying here, this is my common trig table. So my angle is changing from 0 to 90, so that means my angle is changing from here to here. So we knew the sine values from here to here only, right? So it's going to be 1 here, right? So 0 to 1 only we knew. Okay, so that bit is fine. Okay, okay, so this is sine. Okay, let me do cosine very quickly and tan very quickly. Oh, before that, I will finish this one. What is a period? What is a period t here? Quickly. Yeah, but what is that? Length of the repeated block. Length of the repeated block. So, what do you mean by repeated block? If you have sign like this, now we will understand that this part is repeating, right? So, if that part is repeating, so we can see that this is 0 here, this is 2 pi here. So, that is the repeated block. So, what I am saying, I need to find the distance here. The coordinate here is 2 pi 0. The coordinate here is 0 0. Right? So the period would be 2 pi minus 0 and 2 pi. Now sometimes we think that this coordinate would be the period. That coordinate is not the period. The period is this difference, right? Why that is important? If you get the translated version of the graph, then you have to, then this will be shifted here. So you have to count from here to somewhere here and then find the period. Otherwise, don't say that, okay, this to the here. It's not that. That coordinate is not the period, right? So that distance is the period. It's 2 pi. Now, very quickly, how to find the period in general? So let y is equal to sine nx here. So the period is defined by 2 pi divided by n cosine. Okay, so that we know. Now let's go into cosine. With these things we know, and then I'm going to restrict this from 0 to 2 pi. So it will be like that. 2 pi here, 0 here, so it's going to be 1 here, this is going to be minus 1 here, right? So again the period of this one is defined by 2 pi divided by n. Again the same thing. Okay, so this is cosine. All good, guys? Yeah. So then let me do tan. So tan is little weird, so I'm going to do that from minus pi divided by 2 to pi divided by 2, right? So if I do that, like that, so the period here would be pi divided by n. Why pi divided by n? So you understand this difference is what we need to find, right? This difference is t. So t would be, the coordinate here is pi divided by 2 minus the coordinate here would be minus pi divided by 2. So it's going to be pi. Okay, so that is fine. Okay. Okay, so this is pretty basic, yeah. Now we will move into the odd even function concept. Odd even functions. Now it's a even function. It's a even function if this happens, and it's a odd function if this happens. These are the two conditions, right? So we know that. Examples for even functions. All even power functions are even functions, like x2, x4, x6, all even power. Here all odd power, x1, x3, x5, like that. Okay. Now when it comes to sine cos, we have to understand whether we can see that odd even concept. Now let's do sin x. Okay, carefully do this, carefully understand. So if you have sin x, I'm going to draw sin x in this way. So I will draw this part and the negative part here. So here pi minus pi. Then what I'm going to do, I'm going to locate a x value here. If I locate x value, okay, that is too specific here. I'm going to locate x value here. If I do that, this is going to be my fx, right? Actually my y, that is fx here. Fx is equal to sin x, yeah. Now what I'm going to do, I'm going to select a minus x value here. So if I select minus x value here, I'm here, so it's going to be minus fx. Now you can see. Sorry. Minus 6, right? Okay, hold on. F minus 6. For the function, I put minus x. That's what I did, right? So now by comparing these two, can you see that f minus x is equal to fx? Can you see that? No, you can't see, because there are two different points, right? See, fx is not equal to f minus x. If fx is not equal to f minus x, that means this is not going to hold true. Do you understand? So if this is not going to hold true, that means it would be this, right? So you can see here, yeah, can you see that if you multiply this by minus, then this point comes to here, right? So because of that reason, this is going to be odd function. So sine is odd function. So how to visualize it? This way, right? So now let's go to cos function and see whether that is odd or even. Now cos function I'm going to draw in this way. The other part I'm not going to draw. So I would say this is pi divided by 2 here. 2 minus pi divided by 2, I'm going to get that value. So I'm going to take x here. So if I take x, this is the point I am going to have. And if I'm going to have minus x here, I'm going to have the same point here. So this point is fx. So now you can see from here, f of minus x is equal to f of x. So we are talking about the same point here, right? So that means that would be the condition for even, right? You can see even. So this is a even function. So sine is odd function, cos is a even function, tan is a odd function again. Why? Because you can think tan x is equal to sin x divided by cos x. That is our basic definition. So this is a even function. This is an odd function. The final output would be odd function. So you can think minus divided by plus, minus, right? You can think if you want in that way, but that is not that related. Okay. All good, guys? Okay. Next one. So when we are in year 9, 10, we understood this part. Suppose, suppose fx is equal to x squared, comma gx is equal to x. Okay. Solve for x. Right. So this will do. Sleepy. So this will tell you that fx is this, fx is equal to x square is this, gx is this. So you need to find these two values, right? The same question you can write, or the same question you can write, solve x square is equal to x. Same thing. So the meaning of this one is nothing but this whole thing. You understand? Yeah. Second one. If fx is equal to x squared, comma y is equal to 5, solve when fx is equal to y. Right? So understanding would be this is fx, this is 5 here, right? Y is equal to 5 here. So you need to find these 2 points here, right? Or you will see in questions, or solve x squared is equal to 5. Same thing, right? Now you might have seen this business also. Solve x squared plus 5x plus 6 is equal to 0. Solve for x. Now we will decode this. The meaning of this one would be, if y is equal to x squared plus 5x plus 6, comma y is equal to 0, solve for y, solve for x. So we are talking about two different functions here, this one and this one. So we technically equate those two functions, two graphs, right? And then you need to find the intersect point. But you can write that question in one line in this way. Okay, you understand what I'm saying? Okay. Now why I'm giving you this? Okay, now let's do. Solve sin x is equal to half. Okay, I'm not asking you to do it, but I will tell you the understanding of this. Sin x is equal to half. This means, the meaning of this thing is y is equal to sin x and y is equal to half, solve for x. So sin x is this, right? Then half would be this, two lines, right? So you need to find the intersection points and the corresponding x values. The same thing. So if you have this here, you have to consider that this is one function, this is another function. So you are solving it. That means you are considering two functions and plot it and find in the intersection point, like the one you did before, right? You understand what I'm saying? Yeah?
So can I go to the bathroom?
Yeah. So the next one, solve 2 sin x is equal to 3. X is from 0 to root y. Okay, attempt this question. There is no answer. Right? So now sin x is equal to 3 divided by 2. So how do you look at this? You can say this is y and this is again y. So y is equal to 3 divided by 2 and y is equal to x is drawn here. So sin x is this. So the maximum value is 1 here. Now y is equal to 3 divided by 2 is here. This is 3 divided by 2. You don't have any intersection points, right? So the answer would be no solutions. Right? Actually, this question came in the Melbourne High. I don't know why they gave that, but this just to see the consciousness, I think. Okay, so that's fine. Okay. Now, you know common trig values, right? Okay, this we have to understand and remember. So we'll do this quickly. Sin 0, sin 30, sin 45, sin 60, sin 90. Then you get the same thing, cos 0, cos 30, cos 45, cos 60, cos 90. Then you get the tan thing as well, tan 0, tan 30, tan 45, tan 60, tan 90. So I'm just having this here, right? It's going to be 3 here. So sin 0, 0, this is going to be half, this is going to be 1 divided by square root 2, this is going to be square root 3 divided by 2, this is going to be infinity. So now the cos value, cos 0 is infinity, this is going to be square root 3 divided by 2, this is going to be 1 divided by square root 2, this is going to be half, this is going to be 0. So you write in this way, and then you can see this one is here, this one is here, this one here flipped, this one here, right? Okay, so when it comes to tan 0, 0, tan 30, 1 divided by square root 3, tan 45 is 1, this is going to be square root 3, this is going to be again infinity, tan 90 is infinity. Okay, so these things you have to remember. So now if you look into this, so we are interested in 0 to pi divided by 2 till that point only. We are not looking at these things here. So we are looking at the values here only. And if you are looking at the cos, we are looking at these values only. where we are restricting it from 0 to pi divided by 2, right? So in tan, so we have the other part, so it's here. So we are interested, this is 0 to pi divided by 2, so we are interested in the values like these values only, from 0 to 2 pi.
So one question, you know how sine pi over 2 and cos 0 equals infinity? Wouldn't the range restrict the function? So how could, you know...
I didn't get your question.
So let's say sine of x. Sine x, like, isn't the range limited to -1 and 1? That's the range. So how could it surpass? How could it become pi over 2b infinity?
Yeah, that's wrong. That's wrong. This is wrong. I just purposely put that. You guys say why? Dozing off. How come sine pi divided by 2 is 1? And then to support that contradiction, I drew the line as well, the function like here. See, even without telling you, I know that I put a wrong value here and wrong value here because I maintain the same structure, right? And then I saw that you didn't pay attention to that. Then I draw this. Then I put points here. See, this point is there. So immediately you have to catch sine 90. That means here, this is going to be 1. How come it is infinity? No consciousness, and that will happen in the exam too. So most of us realize that, oh, this is how I had to do this question after the exam. You realize it after the exam. But if you prepare pretty good consciously, you can think about that within the exam time. Then you are going to win the game. Otherwise, you do the paper after the exam, right? Then you fail the exam, but you are capable enough to do the exam, right? But that capability you are not going to cater inside the exam time frame. That's a normal thing. That's normal. That's very normal. But the thing is, when we are training ourselves into this paper, all the subjects, we have to take that into account as well. That consciousness, careless mistakes, you write up, how quickly the things are coming. So many things need to fix. Yeah. So that's why. Okay. Now all good. Okay. Yeah. Now I have a question now. Very general question. Okay. Just answer this question. I'm going to give you this. Solve sin x is equal to half 0 to 2 pi. So you have to solve for x, right? Suppose you need to find x. Now you know how to decode this. So how do you decode this? You say this is y is equal to sin x and this is y is equal to half. Then you get that, right? So now you put half here. You put half here. How many solutions you are having now? 2 solutions you are having now. Okay. Now my question is this. You have to find x here. X means the x coordinate of this point, right? X coordinate of this point. So what I'm saying, if you really look into the coordinate here, that would be x1, suppose x1 and half. Y coordinate is half. Here x2 and half. That's the coordinate. So that will tell you that this one is your x2 value, this one is your x1 value. Make sense? Now what you need to find this x1 and x2 value. You don't have to find the y value. Y value is already there. That is half. It's already there. So that's why you need to find x only. Right? No need to find y. Y is already there. Common sense. Right? Now how to find x1 and x2? First of all, how to find x1?
Exact values. The table.
Why? Why table? Okay, so then why you are not finding x2 from the table?
Because it's from 0 to 90.
Because it is from 0 to 90. So if you consciously look into this one, x1 you can easily find from the table. Why? The reason is, if you look into this table values are from 0 to 90. So all these values, this all the x values are here in the table. If you get something beyond this 90, you can't use the table. Do you understand what I'm saying? Right? So this x1 value is less than 90 because 90 is somewhere here. Right? So 90 is somewhere here. So x1 from the table. What about x2?
Your unit circle.
Say it again.
Your unit circle. Because that's in quadrant 2. So you do like pi minus your base value.
Pi minus pi divided by.
Pi minus x1 basically.
Yeah.
Right? Okay, unit circle. Yeah, you can do that. So most of the people do that using the unit circle, right? But unit circle is little dangerous to do, right? I'll tell you how to do it. Now x1, x2 you find from x1. x2, x1 from the table, x2 from x1. Okay, I'll tell you how to do it. Now x1 is direct, right? So how to find x1? So you have half here, so you go to table, so you see half here, so then this is your x value, so that would be 5 pi divided by 6, right? So you come here and straight away say x1 is pi divided by 6 from the table. All good, guys? Now how to find x2? x2 you find from x1, right? Okay, now look. x1 means this coordinate, right? You believe that? This is pi divided by 6. Okay, look. We got it from the table. What is this value over here? 0. What would be the gap here? What would be this distance? Pi divided by 6, right? You believe that? Then how much would this be then? This gap? Pi divided by 6. Again, why? Symmetry. So in sine cos tan, this symmetry property is a big property, important property. So this gap would be pi divided by 6. You understand that? Yeah. So this point is what? This point, pi. So if you want to find this point, what it would be? Pi minus pi divided by 6. You don't have to do unit circle thing, because unit circle thing is little dangerous. I'm not saying don't do, but it's little dangerous if you have a complicated question. So I would say locate and then go for it. Okay. So it's going to be 5 pi divided by 6. Now you know how to get it. You all good? Right? Okay. Let's do this question now. Solve. Sin x is equal to 1 divided by square root 2, right? X is from minus 2 pi to pi. Okay, so it would be this. So half is now this. So first of all, I know 3 solutions, 4 solutions, right? So now I need to find this one first. How do you find x1? Table. So you don't have to do anything. Look, x1 is from the table, that would be pi divided by 4, right? You don't need any unit circles to do this business. Now you can see this one over here, and you see this gap is equal to the other gap, right? So this is going to be pi. So x2 is what? Straight away you can use that logic. Pi minus pi divided by 4. So 3 pi divided by 2. Right? And then you will see again here. Again you go with this gap. So this is going to be minus pi. So this is your x3. So x3 would be minus pi. You are going the negative side, right? So minus pi divided by 4. Which makes sense. Minus 5 pi divided by 4. And if you need this one here, x4 here. So this is going to be minus 2 pi. So x4 is equal to minus 2 pi. Now you do plus. Why? Because you are going this way. Plus pi divided by 4. So it's going to be minus 7 pi divided by 4. You don't have to dance around. You just look at the gap, finalize it. It's just addition and subtraction only afterwards. Right? Yeah. So that is how you solve. Now the basic thing you have to understand is, this is y is equal to half 1 divided by square root 2, which is a function. This is sine. So equating means you are looking at the intersections, right? Which makes sense with our year 9-10 knowledge, right? So quadratics we saw that, right? In 9-10. Yeah. Okay. Okay. So now this question. Solve minus 2 sin x is equal to square root 3. The domain is given. Now first of all, when you have something like that, we need to get rid of this one. So it's going to be sin x is equal to square root 3 divided by 2, but minus. Why? Because otherwise you can't draw the sine function. Why? Because I told you that you have to draw y is equal to sin x. Then y is equal to this you have to draw. If you have that minus 2 coefficient, it's complicated. Why? Because then you wouldn't be able to draw this. This is your sine function, sin x. Not minus sin x or 2 sin x or anything. Yeah? Because you have to draw that so that you make sure your y boundaries are restricted from minus 1 to 1. Right? That is one thing. Now if you rearrange it only, you will see that. Now the other one is y minus square root 3 divided by 2. So that would be this here. Minus. Shakya, you see that?
Yeah.
Minus goes down. Yeah. So how many solutions you are getting here? 1, 2, 3, 4. 4 solutions, right? Now I have a question. The question is this. Now suppose you need to find these 4 you have to find anyways, right? So suppose this is x1, x2, x3, x4. Now first of all, suppose I need to find x1. How to find x1? Can you use the table to find it? No. Why? The reason is, so none of the value is between 0 and pi divided by 2. So that means you can't use the table. Then how do you do? If you can't use the table, that's fine, but try to use it indirectly. Right? Try to use it indirectly. So I'll tell you one thing. In poor countries, in countries like this that never happens. In poor countries, right, people try to rob a lot, right? Why they rob? Because is that their nature? No. Poverty. You don't have it, so you have to survive, right? So you have to rob and need to eat something, right? But in these countries we don't rob. Why they rob? Because that is not direct. So they find indirect paths. We will rob here. So directly you can't find it. So use an indirect path. Now to find the indirect path, will be smart a little bit. Look. Now you understand. Here you get minus square root 3 divided by 2. So that's why you are here, right? That's why you are here. Suppose you are going to get positive square root 3 divided by 2. This line, positive square root 3 divided by 2. Then the intersection would be here, right? Now we are going to rub. Now you can see this value, suppose this is my x prime value. That x prime value now I can see from the table, right? So what would be that value straight away? This is sine, right? Sine 60. This value, right? Right? So that is pi over 3. So that makes sure that this gap would be pi divided by 3. What we need is that gap only. So once we have that gap, so now we make sure that gap is pi divided by 3. That means this gap also pi divided by 3, this also pi divided by 3, this gap also pi divided by 3, this gap also pi divided by 3. So now nonchalantly you can find your x1 value. So knowing this is pi, so x1 value is pi plus pi divided by 3. You know the gap now. X2, this is going to be 2 pi here. So x2 would be 2 pi minus pi divided by 3. Why? Because it's before. Now if you want x3, so it's 0 here, 0 minus pi divided by 3. x4, here is going to be 2 pi. So you are going to write, so that would be 2 pi minus 2 pi, yeah? Plus pi divided by 3. Game over.
Isn't it
Huh?
Isn't it negative pi?
Well, sorry. This is negative pi.
Makes exact sense.
Negative pi.
I know it didn't. No, I didn't.
Yeah. So you get the values now.
Oh, wait, did I?
Can you see how to rob? That's how you do it. Okay. So you somehow use the end of the day. What you are doing, you are using the symmetry property. Okay. All good. So you know how to solve trigonometric equations now. Now when it goes to cos, yeah, the same thing. You use the table, draw it, use the table, get the gap, find the value. Tan, use the table, again get the gap, find the value, right? But the thing is, if inside is complicated, now we'll understand that. Next variation would be, if the inside is complicated, so inside means what? For example, solve sine 2x is equal to half. You get x 0 to 2 pi maybe. Okay. So now you can see inside is complicated here. See, inside is complicated. If inside is complicated, there is only one way to do it. One way, substitution. Right? Method, substitution. So let 2x is equal to k. So then you write sine k is equal to half, right? Now we have to consciously understand that this domain is given for x, right? If you change this to k, you have to change this to k as well. See, x connection and k connection you have to make. Do you understand what I'm saying? Right? So how to make that? Again, easy. Now what you do, This is called your lower x boundary. This is your upper x boundary, right? Now here you need to find k. Now what you need here? Lower k boundary. You need lower k boundary. Okay. Here you need upper k boundary. So lower k boundary and upper k boundary, right? So now how to find the lower k boundary and upper k boundary? Again, very easy. Because of this substitution, this is the only thing that gives you that boundary, right? So whatever the lower x you put here, you put 0 here. So 2 times 0, 0. So k is 0. Next, you put 2 pi here, upper boundary. So 2 pi becomes 4 pi, yeah? You got the boundary set now, right? So game over now. Okay, you understand, Natali? Yeah. Now what you do? Now this is a normal question now. So you make 1, 2, and then you make half here. How many solutions you are expecting? 1, 2, 3, 4. Okay. So I have these 4 solutions. So what is this solution over here from the table straight away? It's going to be half, right? So pi divided by 6 here. If it is pi divided by 6, what this value is? Pi minus pi divided by 6. What about this value is? 2 pi plus pi divided by 6. See, if you know the gap, it's just easy. What about this one? Oh, sorry, this is pi, right? This is 2 pi minus pi divided by 6. That's it. It won't, yeah.
Why is it pi plus pi raised 6?
I'm a little old. So it's going to be pi here, 2 pi here, 3 pi here. Yeah. So I mean, you don't have to dance around now. You know how quickly you get that understanding the gap. Okay. Now, one thing. What are these values, guys? What are these values? K values. Why? Because your x-axis is k now, right? So these are k value, k1, k2, k3, k4. So what I'm going to write now, my k values are pi divided by 6, 5 pi divided by 6, 13 pi divided by 6, 17 pi divided by 6. This is this, this is this. I simplified it, yeah? This is this, and this is this. Got it? Now the question is find x, not k. But we know the substitution k is equal to 2x. Right? Now if you want to find x, what do you do? Divide by 2 everywhere. So it should be pi divided by 12, 5 pi divided by 12, 13 pi divided by 12, 17 pi divided by 12. That's the answer. Not a big deal, right? Okay, so let's do this question now. Question. Solve 2 sine pi minus pi divided by 6 is equal to square root 3. X is from 0 to 2 pi. So now here again we notice these two. So you write, that is the first thing. You write the domain as well. Then in the next one, you see inside is complicated. So you use k. So sine k now is equal to square root 3 divided by 2. So now this should be k. So how do you find the k values? K is this, right? K is this. So you put the lower boundary here, 0. If you put 0, you get minus pi divided by 6. You put 2 pi here. When you put 2 pi, you get 2 pi minus pi divided by 6. You fixed it, right? Now if you think about drawing, now look at the boundary. Boundary is a little weird, right? We can be little smart here. Look how I am drawing it. So my boundary is minus pi divided by 6 to 2 pi minus pi divided by 6, right? What I am going to do, I am going to draw 0 to 2 pi. Then minus pi divided by 6 is, I am just extending it here. Then 2 pi minus pi divided by 6 is somewhere here. So I am going to cut this part. This is my 2 pi minus pi divided by 6. Right? And then square root 3 divided by 2 here. So you get how many solutions? 2 solutions here. So this is my k. Don't forget, my axis is k now. So this is my k1 value. This is my k2 value. So now you can see k1 value from the table. K1 value from the table is sine 30, sine 60, pi divided by 3. My k2 value, you know the gap now. So that would be pi minus pi divided by 3. Am I right? Yeah. So now I get k, which is equal to x minus pi divided by 6 is equal to pi divided by 3 comma 2 pi divided by 3. Then x becomes simple equation, right? Pi divided by 3 plus pi divided by 6 and 2 pi divided by 3 plus pi divided by 6. So you add it, that's answer. Anything? Yeah, understood? Right, okay. So if you know that, you know how to do these questions. Right? Okay, next question. Now we'll go to cos and tan and do the business, okay? Question. Solve square root 3 tan 2x minus pi divided by 6 is equal to 1. Do it for minus pi divided by 2 to pi divided by 2. Okay. Okay, so this question, again I see this one. So tan 2x minus pi divided by 6 is equal to 1 divided by square root 3. Then I am going to say my k is equal to 2x minus pi divided by 6. So once I do that, I get tan k is equal to 1 divided by square root 3. Now I have to put k values here, right? So that would be what you are going to do. You are going to put this one in here. So when you put this one, what do you get? Minus pi divided by 6, right? When you put pi divided by 2, you get pi minus pi divided by 6. Now you need to draw, right? So when you draw tan, first you do the first period here, right? So then the next one. So this is going to be pi divided by 2 here. This is going to be pi here. Then if I draw the next one, here this is minus pi. This is minus pi divided by 2. Now you will see minus pi divided by 6 would be somewhere here, right? Somewhere here. So I'm going to delete this part. My pi minus pi divided by 6, pi is here, minus is here. So I'm going to delete this part. Right, so this is my point. Okay, so this is the boundary now, right? So x is equal to square root 1 divided by square root 3, so that's easy now. That would be somewhere here. So I need to find this point and this point. Two solutions, right? So again, now this is my k. So this is my k1 value. This is my k2 value. So k1 value is straight away from the table. So k1 value is what? 60, yeah? Pi over 6. So now you know that would be pi over 6. So it should be k2 is what? So now you understand that this gap is pi over 6, yeah? So that this gap also pi over 6 then. So k2 is what? Minus pi plus pi over 6. Right? So this is going to be minus 5 pi over 6. So that is k1, k2 values, right? So I get k is 2x minus, k is equal to 2x minus pi divided by 6, which is pi divided by 6 comma minus 5 pi divided by 6. So you can find x from here. So that would be half times pi divided by 6 plus pi divided by 6, comma half times minus 5 pi divided by 6 plus pi divided by 6. So you simplify it, you get the answer.